Okay. We are in a discussion of AWS Solutions Architect, and today we get to discuss some knowledge check questions related to databases, right? What we have discussed in my previous videos, we're going to discuss few questions related to database that can be RDS and non-RDS, right? I'm just going to start from sort of a middle. Uh, all right. So let me move my video controlling bar here, and then we'll look into this question. All right. Uh, okay. As we discussed, this is one of the question, like a sample question. So a company has on-premises MySQL database that handles transactional data. So what do you remember when you're talking about transactional data? OLTP, online transaction data processing, right? The company is migrating the database to AWS cloud, right? So company planning to migrate this RDS type database into the cloud, and then the migrated database must maintain compatibility with company's applications that use the database, right? So that should be MySQL compatible. Uh, the migrated database also must scale automatically during period of increased demand. So that's one of the points of that need automatic scale. So what are you thinking about MySQL PostgreSQL compatibility? Automatic scaling, you should come into Microsoft, AWS Aurora should come into your mind, right? The migrated database also must yeah, scale automatically, right? Which migrate solution will meet these requirements? So you got A to H answers. You probably have to select few of them together, right? Okay, so use native MySQL tool to migrate the database to Amazon RDS for MySQL. That's one of them. Uh, Configure elastic storage scaling, right? Migrate the database to Amazon Redshift by using MySQL dump utility. Turn on auto scaling for Amazon Redshift cluster. Use AWS database migration service to migrate the database to Amazon Aurora, and then turn on Aurora auto scaling. Use AWS database migration service to migrate to Amazon DynamoDB. Configure auto scaling policy. All right, so we got a few different questions. So when you were talking about the migrated database also must scale automatically, so it's come into our mind. Use AWS database migration service (DMS) to migrate database to Amazon Aurora. That's going to be one of the answer. And then what you have to do is, right, you possibly has to turn on Aurora auto scaling to make it automatically scale during the demand, right? And what else you have to do? DynamoDB, no. Auto scaling policy, uh, Redshift, uh, auto scaling Redshift cluster, no. Uh, Database configure elastic scaling. Uh, I think that's will be one of two answers, right? Okay. Um, E and F should be the answer, but I can a little bit discuss uh, SQL uh, native SQL in RDS is also one of the option, but does lacks the part of automatically increase during uh, demand. And then Redshift is Redshift, not a transactional. Redshift going to be warehouse, data warehouse. So it's not compatible with MySQL applications, right? And I think that two answers going to be really working answers, right? And also DynamoDB also not compatible with MySQL based applications, right? So I believe these two are going to be the answers, right? All right, let's go into the next question. Okay, good. Okay, the second question we going to discuss is a company need to configure a real-time data ingestion architecture for its application. All right, so what it says, real-time data ingestion, right? So that may be a real-time data stream, right? The company needs an API, application programming interface, a process that transforms data as the data is streamed. So we been remember we talking about these ones like Kinesis, Firehose, and then ETL Glue, and all other uh, uh, data combination processing EMR might be talking about one of them, and a storage solution for that data. The data lake might be a S3 buckets, S3 storage, or possibly we can put into a Redshift database. Okay, which solution will meet these requirements with the least operational overhead? So least operational overhead means we need to find out a solution with the solution architecture's mind, right? To make sure not much maintenance, right? Manual. So the possibly a lot of things automated, right? So real-time data ingestion coming up, so might be getting a lot of data, right? So let's keep on mind these two or three things. One is the real-time data ingestion, and then API, and then data is streamed and cleaning data, and then you need to somewhere to storage, and then possibly you're going to get the reports, right? That's the last one. So also keep in mind least operational overhead. All right, let's have a look at A to H answers. Deploy a Amazon EC2 instance to host an API that send data to Kinesis data stream, right? And then create an Amazon Kinesis data firehose delivery stream that use Kinesis data stream as a data source. E is missing there. That's fine. Use AWS Lambda function to transform the data, right? Uh, yeah, keep in mind we need the API, right? Use the Kinesis data firehose delivery stream to the data to Amazon S3. Yeah, S3. Keep in mind we need storage as well. Deploy an Amazon EC2 instance to host an API, send the data to AWS Glue. Stop source destination checking on EC2 instance. Not sure where it's coming from. Use AWS Glue to transform data and send the data to Amazon S3, and then configure an Amazon API gateway API to send data to Amazon Kinesis data stream. So many things in there, right? So we possibly need to find out a few different scenarios, right? And Let's see which ones are going to be solutions. Maybe be a few different answers we might have, right? Uh, all right. Let's look into what we needed, right? Okay. Okay. So real-time data ingestion, right? So we talking about something with kinesis. So let's have a look where we talking about kinesis data stream. We're talking about the first answer A, but see that why would you put the EC2 instance to host an API? That's a bit of a overhead, I believe, right? So not sure that answers. So create an Amazon Kinesis data firehose delivery. Use Kinesis data stream as data source, right? That possibly be we can think of maybe we can think, right? Uh, let's have a look. Let's go more further, right? That might be one of the option, I believe, data stream, and then C. What is the C says, right? Use AWS Lambda function to transform the data. That might be another option because it's a serverless, right? So these functions, once you set it up, it does their job, right? And then uh, use Kinesis data firehose delivery stream to data to Amazon S3, right? Uh, can be yeah, one of the solution because here you need a storage solution, right? Deploy EC2 instance APIs and the AWS Glue again. That's something EC2 instance API. I think it's a maybe more overhead thing. Um, Kinesis is more better than when you're getting online streams, right? And then stop source destination checking on EC2 instance. I'm not sure about that. Use AWS Glue to transform data and send to data Amazon S3. So we possibly not going to use Glue. So E and G are out. Configure Amazon API gateway API to send data Kinesis streams. We already created firehose on A and I think not a B. So we're not going to use the bottom one. So create the answers should be create an Kinesis data firehose delivery stream use data source, and then you use Lambda to transform data, and then use delivery stream to send data to Amazon S3, right? And then configure Amazon gateway to send the data to kinetic stream. API gateway, yeah, I think yeah, that one we need as well, right? Okay, so that will give us a four answer, right? This solution going to be Amazon API gateway that need to data to send kinetic data stream, and then AWS Lambda, right? Number C, and then data firehose with S3, right? These are going to be um, answers for that question. It's a bit of a long one, right? All right, let's go into next question, right? All right, so that two a bit of a longer questions, right? What we're going to discuss now, we're going to discuss the a little bit of sort of direct sort of ones, right? So let's have a look. A company runs OLTP migration with high availability. A company runs a high traffic PostgreSQL database for OLTP workload on premises, right? So it's a OLTP, online transaction, which based on the PostgreSQL. So we are thinking something RDS in AWS. They want to migrate to AWS with automatic failover, read scalability, compatibility with existing application. Which solution meet this requirement, right? And we'll have a look what are the answers. So migrate to RDS for PostgreSQL, multi-availability zone, read replicas, right? Uh, AWS DMS to migrate Aurora PostgreSQL with auto scaling. Migrate to DynamoDB with global tables. Elastic Cache for Redis, offload reads. Migrate to Redshift with the RA3 nodes. All right. So, what do you think? Which one going to be? So, migrate to RDS PostgreSQL with multi-availability zones and read replicas, right? That is one of the thing, but when you're talking about the scalability, right, and automatic failover and all other combined effort, I think the second answer would be the best. Amazon DynamoDB is not good for OLTP. Elastic as Redis, it's not going to work. Redshift is not a OLTP workload, they are mostly analytical. So when you're comparing A and B, I believe B is better, faster, read scalability. I think you can get up to 16 uh, read replicas, and then it's compatible with the PostgreSQL application, right? I think that's going to be answer B. All right, let's go into next one. At least let's try to discuss a few different questions about 30 minutes. All right. Okay. So that's next question is NoSQL for semi-structured IoT, right? IoT data, right? A startup collects JSON-based sensor data. So JSON, 10,000 writes per second with varying schemas. Fast speed. They need a low latency serverless database that will scales automatically. Which AWS service is best? Sort of direct question. I don't think you're going to get these sort of questions, possibly direct questions, but just gave you to understand. I don't expect these sort of easy questions in your exam, right? So NoSQL, semi-structured IoT data, right? Devices sending you data. So when you are thinking about something, so we're just going to forget about uh, SQL base, so RDS. So this is definitely NoSQL, NoSQL. So we're possibly going to forget about SQL. So Amazon RDS for MySQL JSON column. Yeah, it's not a efficient solution. DynamoDB with on-demand capacity. Yes, DynamoDB is fast, low latency, right? Serverless and scales automatically, right? Uh, Aurora serverless, it can do, but I think the best option is a DynamoDB here because Aurora is going to be expensive. Elasticache for memcached, Redshift super type data. So Redshift is a sort of a data warehousing. It's not fast as DynamoDB. So this question, I think, answer going to be answer B. All right, let's go into next one. Okay, all right. What is this? Real-time analytics on streaming data, or logistics company need to analyze real-time GPS data streams, right? 1 million events per minute track shipment. So this is like your shipments are moving. They want to store results in a data lake to run SQL queries. Which architecture works best? Right? It might be Amazon shopping. Think about, right? So much you ordering parcels and other stuff. It's something like that, right? Very fast, right? Uh, okay, so this is the real time. Real time. When you're talking about real time data streaming, is what comes into your mind? My mind is coming up with something called kinesis, right? Kinesis is the one thing coming up, right? All right, let's have a look what sort of data coming up. Amazon Kinesis data streams, and then you process with the API with the AWS Lambda, and then you save the data, cleanse data into S3, and then you use Amazon Athena, right? Ad hoc type SQL querying, right? And then Amazon MQ, RDS, QuickSight. I don't think it's going to work. So DynamoDB streams, Redshift, there's no queries there. Elasticache, OpenSearch. Right? This is basically lot for logging time series sort of analysis for OpenSearch. So best answer going to be just stream kinesis, right? And then Lambda to process the data, and S3 to store it, and then Athena to query the data. So this is going to be answer A. All right. So going to talk about next question, caching for high traffic web applications. So we thinking about what sort of cache coming up, right? Cache. How do you pass the application using applications using cache, right? Cache. You got a memory in your memory, so fast access. And e-commerce application experience spikes during sales, cause in database latency. They need to manage caching layer to offload the reads. What solution is the best, right? Uh, so e-commerce applications, they're telling about that experience with sort of spikes, right? During sales. So that causing a database to read the data and give it back to customer. So they're thinking going to get a sort of a caching layer solution and make them faster. So data will be cached and access to customer fast, right? Okay, so Amazon RDS read replicas. So this is you're talking about the latency. Is it not we're talking about heavy read load? So RDS not going to work possibly. Uh, okay, Amazon Elasticache for Redis. Yes, that's one of the caching manage caching sort of a solution, purposely built, right? Elasticache is Elasticache Redis is purpose-built scalable cache for high throughput applications. That's the purposely built one. It's a cluster mode. Um, that's going to be good. Amazon Dynamo Accelerator DAX. That's also the same thing, sort of similar. Uh, Aurora Core caching, right? I think when you're comparing all four solutions, the B is the best solution for this sort of scenario. All right, so go to next question. Might be another easy one. Okay, multi-model database for mixed workloads. Okay, the healthcare apps store patient records, SQL, lab reports, semi-structured document DB, JSON, and time series data, right? They want a single database with ACID compliance, which AWS service fits. Oh, they need ACID compliance, right? And they need a lab report, JSON as well, and then time series data, right? So think about what you want, right? Aurora with PostgreSQL plus DocumentDB, DynamoDB, single database design, Neptune, time stream. Okay, so you want SQL. So then this is definitely going to be the first answer. Aurora PostgreSQL plus DocumentDB. You can use a DocumentDB report JSON as well. So time stream you can't take because you need a patient record SQL. So Neptune is a root detection, relational database system. It's not going to work, right? So the answer going to be answer A. All right. So cost-effective data warehouse migration. All right. What are you talking? A company uses on-premises SQL Server data warehouse 50 terabyte. They want to migrate AWS to minimal ETL effort, right? And columnar storage for analytics. Best option. What is the ETL means? Extract, string, transform, and loading. Minimal effort. And then you need a columnar storage compression to read complex queries, ready for complex queries. So RDS PostgreSQL, uh, PostgreSQL Aurora, and then Redshift serverless, DynamoDB. So it's going to be definitely Redshift. So columnar storage, right? Serverless, parallel processing, a lot of things are there, right? So Redshift is the best option for this sort of data. All right, let's go to next. Oh, easy one. Graph database for fraud detection. What are you coming into your mind? All right. So a fintech company needs to detect fraud by analyzing relationship transaction between users, which AWS service should be used. So that definitely going to be a Amazon Neptune, right? Neptune is the purpose-built graph database, right? So that should be one. That's an easy one. Let's have a look. Do we have another one or two easy questions? Okay, serverless OLTP database with auto scaling, right? What do you come into your mind? So mobile game need database for player profile that is scale millions of requests per day. Zero management based choice. So what do you come to mind? That should be uh, two things, right? That should be faster request. So one is Amazon Aurora serverless version 2, DynamoDB, RDS proxy, MemoryDB for Reddish, right? So that's going to be DynamoDB automatically, no capacity planning. So that should be the one suitable for that. Or let's go to next two questions. Hybrid OLTP analytics workload. A retail app need real-time order processing OLTP and daily sales analytics OLAP. Which architecture most efficient? All right, so OLTP and OLAP. right? They need both of them, right? Aurora PostgreSQL, Redshift, DynamoDB, Elastic MapReduce, EMR, uh, RDS for MySQL QuickSight, Aurora MySQL, and Athena. Right, I think this one as OLTP is Aurora, and then Redshift for analytics, right? The other ones, I don't think we're going to go to the other ones basically, right? So the answer is answer A. Now we're going to talk the last question. Now we're going to talk in today's video. I'm going to talk more questions because I started from here 12th. I've got more complex uh, questions than two answers as well. But let's finish this easiest one. In memory database for session management, social media app requires a sub-millisecond latency for user session. Which AWS service delivers the best performance? Amazon Elasticache for Memcached, MemoriDB for Redis, right? And then DynamoDB with DAX, right? And then you got Aurora with the buffer full, right? What do you think? Which one is going to be the best, right? I think this one is I'll go with the MemoriDB for Redis, right? Durable, compatible, and memory database, right? So this going to be the best for user sessions per millisecond, right? Uh, all right, so that's the question session, and uh, let's discuss this one in one of the other day for another few more questions I'm going to discuss. If you go into here, number two, you got more questions. See that? More questions coming up. It might be a little bit better. Bit difficult. Combined with one or two things. All right. Uh, Going to finish this video. We'll see you from the next video. Till then, thank you very much.